All right, ladies and gentlemen, we are going to get into section 5.4, which again is proving triangles congruent. Yesterday we talked about side, 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 and side angle side, and we also talked about CP, CTC, corresponding parts of congruent triangles are congruent. Today, what we're going to talk about is angle, side angle, and angle, angle side. Now, knowing what you know from yesterday, you can probably predict what this all entails, but let me go ahead and get you started here. So we're going to start with angle, side angle, and here's what it says. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent, okay? So what I did was I marked out two angles to be congruent to two angles over here, okay? Now the included side, remember we said the word included means between, and so between these two angles we have the included side. Between these two angles we have the included side. So that would mean these triangles are congruent by angle, side, angle, angle, side, angle, okay? Now I went and matched everything up. ABC would be this triangle right here, okay? And so as I look over here, A wasn't congruent to anything, so I'm going to put it with R. We went to B, which was 2 congruency marks, and then we went to C, which was 1 congruency mark. So I'm thinking R, Q, P, and that's what we have right there, okay? Now don't forget, all the other parts are going to be congruent by CP, CTC. So I could say angle A is congruent to angle R by CP, CTC. I could say angle C is congruent to AC, is congruent to RP. Hold on. AC is equal to RP, yes, this one, okay? And so, again, by CP, CTC. AB would be congruent to, let's see here, RQ, okay? And we can even say angle A is congruent to angle R by, again, CP, CTC, okay? So, here's what we're going to do. I'm going to introduce a couple of proofs here. I probably included more problems than I really needed to, but I want you to see different ways of doing these proofs. So in this one, we're going to put down the given, the fact that angle BAC, so this angle here, is congruent to angle DEC, that angle there, okay? We also know that BD, this segment, is bisecting AE. Now, if this segment cuts this segment in half right here, what do we then know? We know that this segment and this segment have to be the same measure. So AC is congruent to CE, okay? Now, the other thing, actually I'm going to go back down here to this. Let's not get too far, okay? I went ahead and put down for my second step vertical angles theorem when I already just explained what bisects means. The fact that AC will be congruent to CE if this segment cuts this one in half, okay? But in my proof that I wrote down, I actually went to the vertical angles first after the given, which, as I said yesterday, is wise. If you can look at a picture and you know for sure something's congruent because either you have vertical angles, so you have the reflexive property, you want to make sure that you use those reasons quickly because everything else will come together more quickly for you, okay? So then it says we have the definition of bisects, which we've already talked about, okay? If I can kind of, show this here. All right, I just took my document camera off. I think I just took a picture. All right, so from here, let's see, right there, that's a little better. The next thing I did was I noticed the triangles are then congruent by angle, side angle, and you kind of see that there, okay? So again, ACB is congruent to ECD. Yep, very good, okay? Now, I did include this last step here, and again, this does not have to be included. This is just something I put in so that we can continue to review what CP-CTC stands for. And so if these two triangles up here are congruent, then this segment here and this segment here are going to have to be congruent because they correspond to each other. So that's why I put down CP-CTC, okay? All right, now, another way, we got one more dealing with this, okay? Now, you'll notice here, ooh, get down here, okay. You'll notice here that we have parallel lines here and parallel lines here. I went ahead and marked that out over here. Now, as I do that, when we know we have parallel lines, we need to be thinking about those 3 rules that I put up on the board at the beginning of the week. If lines are parallel, then alternate interior angles are congruent, corresponding angles are congruent, and consecutive interior angles are supplementary. So as I look at this, if this line right here is parallel to this line right here, and this is my transversal, my line in between those two, it means that this angle and this angle here have to be congruent. Those are the angles influenced by the parallel lines. So for step number 2, I put down that angle WZX is congruent to angle YXZ, okay? We also knew that the top and bottom sides were parallel as well, so if I mark that out, this one here and this one here, well, that would then tell me by alternate interior angles that this angle and this angle would have to be congruent as well. And so I wrote down WXZ, so that's that angle there, and angle YZX, that angle there. So I went ahead and did went ahead and said that the triangles were then congruent if you look there by angle, side angle. So we got angle, side angle, angle, side angle. And then I took one more step and I went in and said, hey, we would then know, and you could prove any pair of other sides or any pair of other angles are congruent. I proved the other pair of angles congruent, W and Y. Okay? And the reason I put down is, one, if they are from congruent triangles, then their corresponding parts have to be congruent. Corresponding angles have to be congruent. That's why W and Y would be congruent. You could have also said, the other theorem we talked about earlier this week was, if you have 2 angles from one triangle congruent to 2 angles of another triangle, then their third angles have to be congruent. Okay? So again, just staying in line with the idea of CPCTC. Okay. Now, this next portion deals with the angle-side congruence theorem. Okay? So it says if 2 angles and the non-included side of one triangle are congruent to the corresponding 2 angles and the non-included side of another triangle, of a second triangle, then the triangles are congruent. Okay? So here's what I'm thinking. When it says non-included side, I've got 2 angles. This is my included side, the side that's between those 2 angles. This would be considered a non-included side. This would also be considered a non-included side. So there's parts of this proof or this theorem that are a little vague, but all they're saying is, as long as you have a pair of angles and a side that's not between the congruent angles, and in the other triangle you have 2 angles and a side, and again that side cannot be between the 2 congruent angles. So this would be a non-included side here, so would be C. QR is non-included side, but so would PR. Okay, so you've got some options there when it comes to angle, side, angle, or angle, angle, side. So the next thing I did, I made out my congruency statement. ABC is congruent to, and if you look here, we're going from 2 to none to 1. So I'm going to do QRP, again, 2 to no congruency marks to 1 congruency mark. And that would be congruent by angle, angle, side. Okay. All right, now, to finish things off, I've got 2 more proofs for us. This first one's pretty simple. The second one's got something I want to point out to you. So we're told in the first one that RQ is congruent to ST. That's good. And that RQ is parallel to ST. Well, if they're parallel, things are usually born out of that fact, okay? And so the first thing I did was I stated that RQ is parallel to ST, okay? And if that's the case, then angle R is congruent to angle T. I just pointed the wrong angle, I'm sorry. Angle R is congruent to angle T, okay? Because if these lines are parallel, if I highlight this, if this line here is parallel to this line here, and this is the transversal between them, then this angle here would have to be congruent to that angle there. Okay? Again, that's the alternate interior angles theorem. I didn't show you that very well. So again, this line here is parallel to this one. Here's my transversal. Those alternate interior angles would have to be congruent. I also noticed in the picture that we had vertical angles. So I went ahead and marked those as well as vertical angles. Okay? You could have approached this one from the aspect that if the lines are parallel with this transversal, these two angles would also have to be congruent, which would be true. Okay? But going back to what I did, I went ahead and then stated that the triangles were congruent, RUQ, TUS, by angle side. Remember, that's a way to prove triangles congruent. Okay? To finish things off, I did take it one step further just to say, hey, I would then know that QU is congruent to SU by CP/CTC. Again, they're not covering that right now, but I just want to get that in the back of your minds. All right, now, to finish things off, we have this proof right here. And we were given, well, here's what I did. I looked at my information, DAC, BEC, okay, DC and BC. And I thought to myself, man, there's a lot going on here. These two triangles are overlapping. So what I ended up doing was taking this triangle right here and this triangle right here and breaking them down, how do I say this, into two independent triangles so you could go ahead and work on them from there. You could see things a little more clearly, and that's what I did right here. So in number one, they said angle DAC, this angle here, was congruent to BEC, that angle there, so I'm good with that. I also know that DC is congruent to BC, okay? Now, this angle at C, this one right here, is all by himself, okay? And so I can say that this angle at C is the same measure and is the same angle as this angle at C as well, or the triangle DAC. Okay? So this angle right here is the same in both of these triangles here, CEB and DAC. Okay? Same angle. Now from here, which is why I put the reflexive property. From here, if you notice now, based off what we were given earlier, let me see here, DC is congruent to B, yeah, okay. I know that those two triangles are going to be congruent by angle, side, and we see that right there, okay. At that point, you are done, okay. I took you one step further, and I said, how do we then know that AB is congruent to AD, EB is congruent to AD, and the reason would be CP, CTC, okay. So I realize that was kind of a long explanation over the different proofs there, but it is very important to be able to put all those things together. So with that being said, thanks for paying attention, and we'll see you tomorrow.